Hello, everyone. Welcome to today's Tech Talk. Today we have Chris Tang, who's going to be talking a little bit about Redux 8 and some of the new features. Now, before we begin, I'd like to go ahead and unmute everyone so we could give Chris a big round of applause.
Go, Chris.
Let's
So handsome.
Woo! Okay. Now, without further ado, I'll go ahead and pass it off to Chris so he can give us his Tech Talk.
Thanks, Andy, for that introduction and warm welcome. Before I jump into tonight's talk, I'd like to first thank SingleSprout for sponsoring this Tech Talk. SingleSprout is an industry leader in its aim to hire and recruit technology-driven teams that solve some of the world's most challenging problems. Be sure to check them out at singlesprout.com if you could benefit from their recruiting services. Now, if I haven't had the chance or the pleasure of meeting you yet, my name is Chris Tang. I'm a full stack software engineer with a specialism in React state management. It's my honor and privilege to be taking you all on a deep dive in Redux version 8. With that being said, let's start with an overview of what we'll be covering tonight. So first, we'll start off by building a common understanding of the importance of state in React and how we can go about managing state. Then we'll start our deep dive of Redux. We'll go through the inception of it. We'll have a quick refresher. We'll go into React Redux hooks, and then we'll talk about the new and upcoming features of Redux 8. So let's start with the importance of state in React. So as many of you may already be aware, a key feature of React is its dependable unidirectional flow of data. So an example of this unidirectional flow, you might have an application whose parent component has a container for the data of your app, which is typically an immutable variable called state. The parent component then passes down a snapshot of its state to its child components via a read-only props object. And then the child components can communicate with the parent to update the state via callbacks, which are bound to some kind of button or form in the child component. The unidirectional flow of data can make React more performant and easier to debug than alternatives like Angular. And because state is dynamic, it enables a component to keep track of changing information in between renders, thus enabling reactivity and responsiveness in a React application. But what are some ways we can manage state? So the first option is you can use local state management. With this option, state can be stored locally within parent components and passed down into children through the props object. This practice is notoriously known as prop drilling. While prop drilling may work for smaller applications like this pictured to-do list, prop drilling is not an ideal state management solution for larger applications because of how it bloats your code and makes tracking changes in state and debugging data flow issues much more difficult. So what's next then? We're going to talk about the inception of Redux. So Redux was created by Dan Abramoff, who's pictured here, in 2015. Abramoff began writing the first Redux implementation while preparing for a conference talk at React Europe. To give us an idea of what he was thinking when he wrote Redux, I decided to include a couple of his quotes. The first one reads, "I was trying to make a proof of concept of Flux where I could change the logic, and it would let me time travel. And it will let me reapply the future actions on the code change." Now, before I show you the second quote, I wanted to have a quick aside on Flux and the model viewer controller. So Flux is the application architecture that Meta/Facebook uses for building client-side web applications. Flux is an alternative to the model viewer controller architecture and other software designer patterns for managing how data flows in a React application. Flux complements React and follows the concept of the previously discussed unidirectional data flow model. Now, due to time constraints, we won't be going too much into the MVC or Flux, but you can think of Flux as Redux with multiple stores. And we'll have more on this later when we do our Redux refresher. But now back to Dan Abramoff. Okay, second quote. "I was thinking about Flux as a reduced operation over time. Your stores, they accumulate state in response to these actions. I was thinking of taking this further. What if your Flux store was not a store, but a reducer function?" This shows that Abramoff was struck by the similarity of the Flux pattern with a reducing function. From there, he reaches out to his friend and colleague, Andrew Clark, who's the author of the Flux implementation, Flumux, and they collaborate together on Redux. Now, Redux. Redux is a state management library that builds on top of React. Its three core principles are having a single source of truth, immutable state, and making changes with pure functions. These three principles outline the goal of Redux, which is to impose strict rules on the system's architecture to aid in producing high-quality code and manage state quickly and efficiently without prompt drilling. These principles minimize bugs, create an easy-to-follow front-end structure, and make adding new features easier. Now let's do a refresher on how Redux works. So I'll walk us through an example of how an application would interact with a Redux application. As you probably already know, this entire process is cyclical. We're going to begin our example with the user interface. So that would be this blue square here. This is where a change is triggered. An example of this may be the user clicking a plus button in an application that just kind of counts up. So clicking the plus button will then trigger our actions, which holds the actions we want to take place. An example of this would be add one. In Redux, actions are plain JavaScript objects, and they must have a type property. In this case, for our action of add one, the type property could be the string add_1. The action is then sent to our reducers, which are pure functions that specify how the application state should change in response to each action. For example, our new state should be one integer higher than our old state. And as a fun fact and aside, it's reducers that give Redux its name since they share the same Latin root. From there, from the reducer, we now send an update to our store. The store is where everything comes together. It holds our application state and is where we find three critical methods of Redux: get state, which allows access to the state object; dispatch, which allows state to be updated; and subscribe, which registers listeners, allowing code to trigger every time a change takes place. Within our store, we're going to get to our last step of the process, which is state. As I mentioned at the beginning of our presentation, state is an object that represents the dynamic parts of the app. In our example of a counter app, the state object will contain whatever number our counter is on. This change is then communicated back to the user interface, where it will finally appear to the user. And that is the Redux cycle. So something that I wanted to highlight is that in 2019, with the release of React Redux version 7.1, there came the arrival of the long-awaited support for React's Redux Hooks. A high-level way of thinking about using Redux with React Hooks is that you can replace Redux's connect function that connects a React component to a Redux store with some of the new hooks that have been provided. Now, I know it's a lot of code to look at, but I just wanted to include these two code snippets to illustrate how straightforward and easy implementing React Redux hooks is compared to using the connect function. And to summarize these changes, there are two hooks in the right-hand side code snippet that I wanted to draw our attention to with the gray arrow. The first one is the use selector hook, which is analogous to connect's map state to props. We pass it a function that takes the Redux store state and it returns the pieces of state you're interested in. And the second is the use dispatch hook, which replaces connect's map dispatch to props, but is lighter weight. All it does is it returns your store's dispatch method so you can manually dispatch actions. And last but not least, we'll end with an update on the two main new features of Redux 8. As a quick overview, TypeScript is very similar to JavaScript. So the first big update is that the entire code base has been refactored into TypeScript. And the main difference between JavaScript and TypeScript is the way that they're typed. So the difference between that is JavaScript is dynamically typed language, which means that the types are checked and data type errors are spotted only at the runtime. Runtime type checking is not necessarily a disadvantage since it offers more flexibility and enables program components to adapt and change on the fly. But the larger the project and the team, the more undefined variables are added and the more potential mistakes the code amasses. TypeScript introduces optional strong static typing, which means that once declared, a variable doesn't change its type and can take only certain values. The compiler alerts developers to type-related mistakes, so they have no opportunity to hit the production phase. This results in less error-prone code and better performance during execution. But static typing is not only about catching bugs, it also gives the code more structure, makes it self-documenting and more readable, speeds up debugging and refactoring. All told, TypeScript increases productivity across a large team. So the refactoring of the code base into TypeScript is a huge improvement because the strict static typing of TypeScript is much more suited for enterprise level applications, which coincides with the main use of Redux for global state management. And the second big feature with Redux 8 is the compatibility with React 18. Specifically, the new useSync external store API allows React to work properly in concurrent mode and sync with an external state from Redux without tearing, meaning that the UI can't become inconsistent with store state. The useSync external store hook will detect changes in external state during render and restart rendering before showing the inconsistent UI to the user. So the user will always see a consistent user interface. And last but not least, I have some additional reading. I'll send these out with the slides if you want to read more about this. And I'd like to thank you for your time.
Awesome job. Everyone, let's go ahead and unmute ourselves and give Chris a big round of applause.
Oh, Chris.
Oh, Chris.
Chris.
Some complex stuff.
Okay, cool. Well, now with that being said, we'll go ahead and open the floor to questions. Would anyone like to ask Chris Tang a question about his tech talk? Cool. I have Jacob. Go ahead.
Yeah, Chris, amazing tech talk. Thank you for taking the time to do that. So in your presentation, you mentioned a lot of pros. Sorry, for using Redux as an alternative to like local state management with prop drilling, but I was wondering, are there any like disadvantages to using Redux and why you might use something else?
Yeah, that's an excellent question, Jacob. Thanks for asking. So there are a few disadvantages to Redux that may be relevant depending on the needs of yourself or your team and your application. First, there's a considerable learning curve involved in learning Redux, which can become difficult if working on a tight ramp-up schedule with a team of engineers that's unfamiliar with Redux. Also, Redux tends to make less sense for smaller applications, and there's quite a bit of boilerplating, especially if you're not using React Redux hooks. And last but not least, even a minor change in Redux triggers the DOM restructuring process, which is time-consuming and can adversely affect performance for the end user. If you think these factors are important to you or your team, I would suggest exploring other alternatives like MobX, Apollo GraphQL, or the context API that's native to React hooks. Thanks for your question.
Awesome stuff. Before we end, does anyone have any more questions? No? Okay, well, everyone, thank you. That concludes our tech talk today. I hope you guys have a great rest of your Saturday.